Boom, boom, boom. All right. Okay, there we go. I don't know why that even has an audio bar. Can I move this up? It's just going to be a pain in the ass right now. But what's good, people? A long time no stream. Maybe. No, that soundbar is not working. There we go. Always a pain in the ass. Sweet. All right, we are back. Long time no stream. So right now, kind of switching gears for a little bit. Doing kind of putting the web scraping, data science stuff on the back burner right now for a little bit. I kind of want to get a little more practice off stream before I start doing it on stream, just because I think it does kind of make for a little bit of a boring stream when it's just kind of beating my head against the wall trying to debug kind of beginner level shit. So what I figured I'd do in the meantime is actually get IPython paint. Up here is, for a while here, I started working on this kind of little PhysicsOne solver app Thingamajig. Bool object has no object TK, which I started working on a while back and then just kind of put on the back burner for a while. So I figured, okay, this might be something that might be useful. It might be fun to do on stream. So figured I'd give that a shot for a little bit. And as we can see, after not working on this for quite a while, it is already broken. Oh, I think I remember this issue. I was trying to get it so that I'd get like a little icon thing popping up when, because I got this little, maybe? No? Open externally? Photos. Yeah, so I wanted to get it set up so that, you know, I'd get this little stock image icon for like down here on the toolbar, but apparently that's been fighting me a little bit. No, don't share. So in the meantime, we are just gonna say to hell with you for the time being. We should get, I don't know what that's about. Yeah, this little guy here. Cool. So, start page, what kind of problem? So right now it's set up so you can kind of click 1D motion and then you can kind of put in whatever information you want in here. And then if you just click solve, it'll solve for the things, the unknowns that you have here. What did... So if we start at like 0, we want to end at 10. If we start at rest, I don't know what the final velocity is going to be, and it's going to take us like 5 seconds to do that, and we click solve. We are going to get some errors here because I haven't done this in a while, and so apparently it's just going to fight me for a little bit. Solve x variable dot get what 146. So mainly I haven't touched this in quite some time, so it's going to be a bit of a process of figuring out what the fuck this was doing when last I worked on it, and hopefully just kind of chug through, because eventually I think the end goal is to have all of this, have like all the topics that you would normally cover in like a Physics 1 intro class, and then it'll be a nice little solver tool, you know, trying to get projectile motion up and running. But apparently 1D is also just not working right now. So why is that 146? And here, have self variable dot get y. So what? String object has no attribute get. So why is this a string object? Let's just look for set. So if I remember correctly, the way that Tkinter works is that I have string set. But even then, list of all the variables. Where else is this gonna be? There. There. Oh, okay, because I do set it when I hit the clear button. I'm setting it. Oh, okay, I am just changing the type. And this is one of those moments where it really sucks dealing with Python. Because Python will just let you change the type of the variable at the drop of the hat. So do I even need... See, I think all of these need to be sets. And do that, just like how up here I'm setting it to a string of whatever that is. Boop. So now if I do 10, or let's have it moving in the positive 10 initial, we'll start at rest, and it'll take us 5 seconds to do that. No, wait, maybe. No, it's just being ridiculously slow. All right, close that out. Restart it. 1D, 0, 15, yeah, sure, we'll give it 0 acceleration. What? Oh, okay, yeah, not doing anything. It takes 5 seconds. Solve. Boom. So this is what it should be doing. Give it some set of knowns. Click solve. It'll fill in whatever it doesn't know. And then right now, I've got a nice little plot here. And when we clear, fuck. Why pyvar 11? No. Fuck you. So when clear button, it clears all the text boxes. So we're setting the variable. I don't remember how exactly all of this is set up. So I know I have a text box. Variable. That's when I click solve. But where else is this? Clear button set. It's a Tkinter string var. Setting up all the text entered. I'm giving it some default value, so that's where that 10 is coming from. And Y, text box insert. What type is this? Text box. It's an entry. Self text variable. I'm giving it this thing as the variable in there. Convert a number or string to an integer or return 0 if no arguments are given. If x is not a number, delete. What? Oh no, it's doing delete first, last. Oh yeah, because the text box is treating it as a string. I just want to delete all of the characters in there. So this is just clearing whatever is in there. And then I want to insert. Why do I want to insert something? Insert. Yeah, this is the solve. Oh, because, yeah, this is the solve. So I want to delete whatever is in the text box and then take the answer and put that inside the text box. Here's what all that's doing. This is setting those to 0, it's deleting, and then I'm grabbing this variable and putting it in there. But why? And why is that showing us like pyvar 11 when I'm doing like an empty string like that? I think I need to double check what the string var is doing. Kinter string var. Var container value name, which is I think what Kinter. What? No. Come back. The container is going to be self. The value is 10, and then I didn't give it a name, which I'm probably okay. A TCL name that defines pyvar num. Okay, not really sure why. I guess that's why it's doing that. Doesn't really make a lot of sense to me. Text variable, or you can assign it to the text. After creating a string var object, you can assign it to the text variable of a widget that accepts a string var object. For example, string var, text var to the entry widget, text var, string var. Yep. Get trace callback whenever the value of the string var object changes. Use a trace method. EW mode will automatically invoke the callback whenever the value of string var changes. String var also provides R and U, R read, invoke a callback whenever the variable is read, U unset, invoke a callback whenever the variable is deleted. Okay. App, super, don't know why. String var object in the init method of the app, which we've got there. Second, assign the string var object to a text variable in the entry, like that. Self output label. Third, set the text of the output labeled widget. Config text self name var this guy dot get. Text of the output. Config error foreground. Yes, I think I'm doing something with not the get. This. Set the variable to value. So why isn't... So why is this text box inserting... Because it's inserting the variable. So I need to add a .get at the end of all of these. Because for whatever reason, when it's making these, it's grabbing like the variable name, which is like why I'm getting that pyvar on all of that. Close that out, rerun that, go to 1D, to 0, 15, sure. It'll start at that. Who knows what that could be? And it'll take 5 seconds to go. Boom, start at 0. I want my final position to be 15, which is where that is. Initial velocity of 1, which is why we already have a little bit of a slope there. And I want it to get there after 5 seconds, so assuming uniform acceleration, I've got to be accelerating at 0.8 meters per second squared to get me there. Clear, and we're empty. Nice, cool. All right, so obviously a whole lot of things that could be improved on this guy, but it does the gist for it now. Now the hard part, or the difficult part, the fun part, I don't know. The interesting part with the 2D ones, I'm going to want to be able to do it in kind of two ways, where I'll have kind of the angle magnitude method and like the initial XY method. Because a lot of times close that, new. Because a lot of times you're just like, all right, here's some V0 at some theta naught above the altitude, and then you can break it up into your like X naught and Y naught. And so I want to be able to use like both inputs to do this, which is just going to be a little more work on getting like this screen up and running. Boom. Okay. So I want to get rid of you and you and you and you. Boom. Now I get my 2D motion page. So I'm actually probably going to want to uncollapse all that here in a minute. So we got a clear button, lambda clear button. Solve button does nothing right now. Clear button is not even defined, I don't think. If I clear this, it should just, yeah, error out on me, which is a-okay. All right, so first thing I want to do is the solve. So right now, what are my possible inputs? Right now we've got initial velocity and the launch angle. And so for now, I'm just going to try to solve the time in the air, max height of the projectile, and max height of the projectile. I probably don't want max height of the projectile. I probably want something to do horizontal distance of projectile. Distance label grid, do. Boom, boom, boom. I do want to get the canvas on here. So I'm just going to grab this. Throw that on there. See if that actually worked. Cool. That'll air out. Nice. So we have my little canvas on there. And I have some initial inputs. 1D motion. Okay, that's the starting page, which I do not care about. Quick print Y. Why do I have this? I have the worst chat ever. Why do I have I don't know, like what? I have no idea what on earth I have that for. Alrighty, so grab our paint. Fucking erase all that shit. Alrighty. So this is where I really wish I had like an iPad or something. And I can just like draw on it and it would pop up here. Because that would make this a hell of a lot easier. So in our normal Physics 1 problem, let's make, yeah, that's fine. Normally we will have some V0 and some angle theta naught. And so the first thing we want to do is break this up. Do a better dash line than that. So this is some V0 at some, we want to break this up into some X component and some Y component. And so my initial velocity in the x is going to be my v0, the magnitude of this vector, some angle here that's going to be the cosine of theta naught. My y naught is going to equal v naught sine of theta naught. And then the rest of the projectile motion, because we're just in 2D now, is going to work the exact same way that it did in 1D. So normally that's 1/2 at squared plus v naught t plus x naught is going to equal my position. And so all that we need to do to make this work in the 2D is add little subscripts on here. So we're going to zoom in so we can hopefully draw a little better, but this is just going to be the acceleration in the x direction times t squared plus the initial velocity in the x direction. Actually, no, yeah, this is, ignore this. This should be not position, because position will just be told, but this will be like v naught y and v naught x. T plus its initial position in the x direction equal that, and then 1/2 a y t squared plus v naught y times t plus y naught is going to equal y. I gotta try to figure out a better thing to do with the camera, because I keep getting cut out of frame. So this is pretty much just the exact same thing that we just did, which is nice, because that will hopefully reduce the amount of work we need to do, because then all of the projectile motion equations that we used here in the 1D solver, all of these guys are gonna be the exact same. For the 2D case, we're just gonna add little subscripts, and just, you know, the initial velocity in the x direction, the initial velocity in the y direction. And the really nice thing is that if we're dealing with, you know, projectile motion like this, like, you know, you throw a ball at some angle with some velocity, this guy right here is going to go to 0, which is super nice because there's no acceleration in the x direction. If this is my x, this is my y, then all I have, nope, let's try to get this nice and straight down. This right here is going to be my gravity going just down in the y direction. So that means this whole thing, yeah, is going to be gone. And so now we just have pretty much these two equations that we want to solve for. And we know what these two variables are going to be, because these we can just pull from over here. So when I click on, nope, my 1D solver, probably gonna want that positive quadratic here. So right now, the way I had it set up, how did I get this set up? So make a list of all the variables that we have, put that in the dictionary, and then I just hit it through those into the one-dimension solver, and then it returned those variables. So yeah, I'm pretty much just gonna want to steal this. Boom. Now we're just gonna need to modify it a little bit, because now my initial variables are just going to be, at least for now I'm just going to assume I'm always starting with V0 and theta. I'm just gonna deal with the simple case for the time being. So this is pretty much just going to look at whatever we have in that text box. Let's just change this. Alright, so we're just going to assume we got V0 and theta on these. Change these. Nothing, set that equal to none, else grab those values. We're just going to delete all of these. For now, actually, no, I don't, because I'm still going to want those to be in the variables. So what else do we have here? Where is, let's just save. Is this going to yell at me? Probably. Let's just do that. Gonna yell? Okay. Boop, 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 boo, doo, boo. You go over there. You go over there. So I've got my V0, I've got my theta. I'm going to want T, which I'll have there. I'll probably... variable. Time variable. Apex, Veda, boop, boop. All this, I'm just gonna call it Apex. Boop, boop, doop, boop. Distance. I think that's all I've got. I've got V0, theta, time, apex, distance. That was V0, theta, apex, distance, time. Cool. So just gonna assume that all of those are the case, so then I need to move all of these guys down here. Move, come on. There, we get rid of A. And then we just have T. I really should be a better programmer and just call this time. But there is the possibility, since time I think is, actually, no, for now I'm just going to leave that as T. Okay. Doop, 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 doop. Okay. So for now, all that can stay, excuse me, as is. Then I need to go into the actual physics solver. I don't know why this is being like that. Physics solver in here. This is the one-dimensional solver, which we're probably just going to need that some more. And we're just going to need the def2. What did I call this? The whole one-dimension solver. Yes, I did. We're just going to do, well, that and change. Cool. And then, so we'll just steal that for that. And we just gotta swap out that. That can go like that. And we'll go into here. And we'll grab all of these guys. this a little bit cleaner. Update, so then it should take this and update it with that. Update it with that. We'll have a variable mask. Boom, boop, boop. Now it should over only be like boop. None is in variables dot values. So while any of those are none, we will keep on trying to solve. And so for right now, since I'm assuming that I've already got, we're just gonna nuke this. Wait, no. Yeah, I definitely want that to be a 0. Boom. Okay. Work on other cases later. Okay, I've had enough lo-fi for now. What do I feel like listening to right now? Boo 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 do do do. We're feeling a little sleepy right now. That can only mean one thing to listen to. No, start at the beginning, please. Oh. Alright, no more sleep. Stay awake. Alrighty. So we're assuming we got those two. So I think the first thing I want is to plug in, get my Vnaught for both of those. Vnaught Y is going to be, I've got NumPy. I don't know why I have SciPy. Variables. Vnaught times NumPy cosine. Yeah. NP sine variables theta. Oh, other way around. Sine cosine. So if it's going up like this, it's the other way for you. Whatever, screw you guys. It's going up like this. Parallel x is going to be cosine. Opposite sine. Yeah. That's good. I'm going to turn it down just a hair. I'm going to turn that down a bit. That'll give me my x and y. So if I want to, so if my projectile is going, okay, it is. Turn this down. There we go. So I already know my projectile is going to look a little bit like this. So right now I want to find this right here is going to be my apex. This and that is my apex. This is my distance. Alright, so what do I know about getting up to the apex? This is where we got to use a little bit of our physics-y and knowledge here. Well, I know that when I get to the top here, I'm going to have some delta y. So I'm pretty much doing y apex is going to equal 1/2 a t squared plus whatever that initial velocity was in the y direction times t plus whatever my y naught was. So in this case, my y naught is 0. My v naught y, that is going to be my no, because I'm not gonna know. Yeah, okay, brain fart. So this isn't really gonna work because right now I don't know what apex, I don't know what t is, I don't know how long it's gonna take me to get to the top point there, but I can use one of these other equations here because I do know right off the bat something about my velocity at this top point. So I know that my velocity final, not when I land down here, but my final position is going to be the apex up here, and I know that that velocity is going to be 0. Because my y position, if I were to just plot out, or if this were like y, and instead of x, this were like time, my y position would increase for a bit, and it would stop, and then it would go by. I mean, that's literally what I plotted here, but just as a function of x rather than time. But effectively up here, my derivative, or my velocity, is going to be 0, because I'm going up and then I'm switching over and then coming back down. So that means my velocity has to be 0 at that apex point. So if I know that my final velocity is going to be 0, well then instead, so if I know my final velocity is that and I want to solve for y final, and my time is unknown, I could try to get another equation, solve for time, and then solve for y final, or I can just use one of these. And right now I am thinking the easiest, because this doesn't have it, is going to be number 3 here, because there's no time. So if I know that my, how do I make my canvas be bigger, please? It's gonna make everything bigger. Fuck you. And go back to brushes. Alright, so if I know my V final squared is going to equal V naught squared plus some other shit, 2a delta x plus 2a x final minus x initial. I know what a is. A is just gravity. This is my initial position, which I'm assuming is, for right now, I'm assuming we're always going to be starting at the origin. And then I'm going to have my x final, and so just doing a little bit, so my final velocity here is going to be 0, and I want to solve for x final. So that's going to be negative 2a xf minus x naught equals v naught squared. I want to divide that out, so I'll have xf minus x naught equals negative V0 squared divided by 2a. Then I want to solve for that, so my x final, I guess in this case I should be using y because I'm doing this all in the y direction. It's going to equal negative V0 squared divided by 2 times the acceleration plus whatever that initial position is. So boom, that right there is what I want to get my peak position. So, actually all of this, okay, actually I should think about this a little bit because I am going to want to solve for a bunch of different, I'm not just going to want to do starting at 0, 0, you throw it, it lands at some. I'm also going to want to do, like, what if you're standing on a cliff? And then the base of the cliff, you know, here is some why not that I might have. And here I am, zoom in a little bit. Here's me. I'm gonna throw this ball with some angle like that. It's going off. I might want to like look at this here, get that apex in this distance. And similarly, if I'm, you know, if we have it the other way, where I'm down here like this, I'm trying to throw it up there. I'm eventually going to want to do all of these situations. So I should be a good person and not take the easy way out. Fuck, I'm so sleepy. God damn it. How is there? I don't know. Well, it doesn't matter how much coffee I drink in the day. I will still be tired, like, throughout the day, no matter what. Probably because I have an addiction, and so drinking a pot a day does nothing for me. So, how do I close this? No, go here. Get rid of you. Go here. Okay, go away. Alright. So since I want it to be nice and flexible, I should be not lazy. So what else do I need on here? So like those are things I can solve for. What else? I probably want an initial position. Come up here rather than have this be like yeah, sure, let's go X0. X0 label starting X position. Put it the row count. So I'm just taking that up. Go here. X0. go over here. Why not? Starting Y position. Fuck, I have half a mind to go grab a Red Bull right now. Maybe several. Alright, so we got... See, this is like such bad, because like right now, I'm just so far off the camera. I need to, yeah, definitely figure out something better to do with the camera. Why are you yelling at me right now? Probably because my internet here sucks. Fucking bullshit. Okay. Boop. My variable time. What else? Probably what I'm going to want, because if it's a flat ground case, wonder what would be the best way to indicate that we're doing like a change in elevation type problem. I guess the one way would be to have like a little checkbox or something that would kind of toggle or just allow the user to like assume that it's level ground unless, you know, explicitly stated other. Okay, yeah. I think okay, yeah. Oh, whoops. All of these I've had distance label. Like a fucking idiot. Boom. Lean back. Stop leaning forward so much. Alright, then we got the final label. Next final there. Why not? This will not be why not. This will be final Y. Final. The label will be TK label self string starting final. Anything else? Anything else? I think that's all I want. Apex I still want, but the distance I do not need anymore, because that is just X final. That should be easy enough. I don't know. Where is... I guess I did turn that down a lot. Alright, let's... Ooh. Maybe a little too much. Okay, alright, okay. So I've got that. Let's save all of this. Close this and kick it off again. Go here And everything is all bad. This is bad. Okay, what went wrong? Probably because I have these column counts here. Get rid of all of you. Row, and then I only want to do col counts on that last one. Kick that off. Projectile. Still not row count. Oh, and then I reset it equal to 1 after all of these. Man, I'm not sure how to do this. What the better way to do this is, but I want to believe that there is a better way. Row count equals 1. Try that again. Yay, there we go. Now I've got my initial velocity, my angle. Other thought is thinking. Yeah, I think what I want to do is just on the theta thing. The theta thing, I'm a little worried about people putting it in like degrees or something, but I think, you know, just do rad. Hopefully that's enough for people to remember. And we'll assume this is all MKS, as one should be doing, at least in Physics 1. Meters per second, radian, noise. Text box entry, it's doing the full, which I'm okay with. Ooh, yeah. I can definitely see, would be nice to add the option as number inputs. So like for example, would be nice, you know, if it just knew, if it, you could just do something like pi over 4, just or if I did like 3 pi over 2 or something like that. I guess for projectile motion you would only have things like 0 to pi over 2 would be the only range of like radians that you would ever deal with. Auto convert, and degrees, degrees. If we're doing that in degrees. Doop, boop, boop. Boop, ba doop, boop. Okay, so we have to say blah, 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 blah. Fuck. I'm sleepy. So goddamn sleepy. Yeah, this might end up being kind of a short stream tonight, because I don't know why, but I am just really fucking tired. Alright, so we got all of that set up. So now, when I click the solve go to all those little text boxes. I need to add all the other ones now. And that's what I say. And I wish there was a way I could just like collapse bits of code. Wait, am I doing this in the wrong spot? Yeah, I don't. Oh god, what happened? Okay, yeah, there I am. Dead. Now I need to go through. There's the graph bits now in the 2D part. When I click. What the? Oh yeah, that's my solver. Okay, so now in my 2D motion page, when I click the solve button, I want to go through all of those different text boxes and I need to get rid of distance right off the bat. No. Grab one of these. Self. Excellent variable. Not float. X not. Because that's in string, so I want to get that, turn that into an actual number. Put that there. Cool. What else do I need? What else? I got my initials, my finals, my time, my apex. I think that's everything. Why not? Why not? XF. YF, got my apex, don't want distance no more, and I've got my time. Cool. Alright, so now what I need, variables y unnamed, blah blah blah. Do I want to do, oh fuck, I probably also want final velocities on there too, because I can definitely see a problem where I throw like a projectile, it like sails through the air, and then I want to know like how fast is it going to be going, because like I throw it off a cliff or something, and then like, you know, ignoring air resistance and all that jazz, how fast is it going to be going when it crashes into the ground? I don't want to. Okay. All right. So we're gonna grab this. Do that there. The velocity. I guess we'll do y vel f. I'm doing x first for all of these, so we will do that. X velocity final. Fuck, I can't remember right now. It is, right? Yeah, it is C. Oh, fuck, I'm tired. Doing this after work is the main reason, yeah, that I haven't been doing much streaming lately is because after programming all day at work, coming here and doing more programming stuff is a little on the tiring side of things. Do Y. No, go away, please. Come on. So many fucking things to solve for. Which angle, starting position, starting Y position, final X position, final. Where'd my little text box thingy go? X final variable, text box, label. Where did you go? Right there. Nice. Starting X, starting Y, final X, final Y, final X velocity, final Y velocity, time in air, max height of projectile. Cool. Should just air out. Clear does nothing right now. Okay, progress. So, now that I have all of that shit done. That. God damn it, why am I spending so much time going over the final Y? Or no, this is X. FX. VFX. Width. Regular expression, find next, replace text. Yeah, take any y underscore vel underscore f and replace it with b final y. No matches. What do you mean? we go. Fuck you. What is that? Yes. Yes, 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 yes. Yes, cool. Alright, boop, 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 boop. So all that's done. So now that I'm in here, I'm gonna do the same thing that I've done for all of these. I'm realizing I should have just switched the order on these, because I could just be adding a Y there, or a V in front of all these. Right now I just don't give a fuck. Okay, we got that. Ah, cool. VFX. Alrighty, so now that I go back into my actual solver, I will not be assuming anything. Okay, so now I just need to go through all of the permutations that we have here. So I'm going to have Vnaught X and Y, X naught, Y naught, X final, Y final. Apex, or I guess we might just call this Y max. We're going to have T, and then the velocity final, X and Y. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For a whopping 10 fucking unknowns, dude. Alright. So now let's just, get to work. Alright, so for Apex, I'm pretty sure the only way to solve for the Apex is what we already did. Where Y... zoom in some more. Max is just going to be equal to negative V naught Y over 2 A in the Y plus whatever my Y naught is. Alright, because if I go back to this, so that's 0, subtract that, divide by negative 2A, negative V naught squared, divided by 2A, add the X naught. Meters per second squared divided by meters per second squared. Plus in meters. Oh, big stretch. Oh, fuck. Okay, so I think this is like my one and only Y max equation that I need. So as long as I have these three things, I should be good. The rest of it is going to be, I'll have 1/2. It is just going to be all of these, but doubled. Trying to think if there's anything else kind of blatantly off that I am missing. right now. And it does none for everything, and then it does the update. So if I do that, wait, no. I'm gonna go like wapa. And we're gonna do a none, and then another none, and then a few more, just for good measure. I fucked this up. Why? Okay. Why did I do that? Okay, there we go. Oh god, zoom, no. Bad. Okay. Now that I got that out of the way, I want to start with copying that. Putting that down there. Then we're gonna take this, copy that, put it over here. Now change all of these to none. I was wondering why I had such a huge gap there, and it's because I accidentally deleted all the code. Then I want to take the keyword arguments that I will be passing in here. I actually wonder if I could just pass in that's already a bunch of nuns. So why am I doing this? I could, because I'm already pretty much, I don't think I'm ever going to be solving this. I'm going to try it doing this way. That'll be there, that'll go there. It'll either be none or whatever input value I gave it. I'm gonna need to do a strip just in case I have white space on these. Alright, so that'll go there. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there we go. Whoops. Yeah. No. Yeah, there we go. Alright, so when I get to that one, just set that like so. Is not none, then variable mask plus equals he is xf and item is not none. Variable mark, no, not mark. Mask plus equals y final and item is not none, and variable mask. We would like to add on to that guy, then else if key equals final y and item is not none, and I want variable mask plus equals all of that jazz. Else if key equals and item is not none, and the variable mask. I don't know why you keep trying to treat this like it's a function. Else if key equals fuckity, what did I miss? Vnaught theta VF YF. I skipped final x. Key equals and item is not none. I want a variable mask. What the? I'm sure what that was about. So right off the bat, assuming Vnaught and theta are going to be my two most common types of solving. This I can get rid of, at least for now. Stupid net. All right, so I have a loop count. So the loop count I kind of have in there just so I can break out if I get stuck. I don't want this. I don't really know exactly. So the reason I had this set up like this is that initially I have this, so as long as any of these are none, I just want to keep iterating through all of these solves until I get it. Because the first time I go through, depending on which variables I've given it, it might, just solve for A first. And then once I have A, I might be able to go back and solve. Excuse me. Nose is all itchy. Solve for one of these other variables. So I just want to keep trying to loop through this over and over again. I probably could be smart about this and try to map out all the different possible inputs, and then just be like, all right, well, if you have this initial set of inputs, then this is how you can solve this the fastest. If you have this other set of inputs, then this is how you can solve for everything else the fastest. And might be able to do that, but that seemed like more work than just kind of hitting it like, okay, given any of these possible initial setup combinations, what's going to be the best? So yeah, just with any of these variable combinations, then hey, you can solve for x naught using this equation. So for now though, we're just going to stick with that. So get initial velocities. And actually what I should do is, unless otherwise stated, if that's blah, then all of these xf will be some positive position in the x direction. But I'm going to assume that for unless otherwise stated, I'm just going to assume we start at 0, 0 and we end back on 0. Then if that's not the case, then there would be, there'd be some user input. You would know. Actually, would that be the case? Because it could be. Yeah, I guess I don't know. Feels like a safe assumption, but there's always that one weird corner case where it's not like that. But I think that does mean that I'm going to set up a 10, 4 in here. That I can set up a default value at least for these. And then it's final. Don't know what that's going to be. 0. So that way, at least when we kick it off, it'll have those initial values. And then I guess if you don't know what it is, you can just delete it. But having that set as a default seems like a pretty safe bet for x and y. So, for all of this, I did if I and that, and I just have those first two. theta. I don't have any. Let me think about this for a second. Do I want, I mean, it is possible that I'm not doing, yeah, like a Vnaught theta solve 10. Sorry, I'm thinking, because right now, yeah, I'm trying to just think if I want to add kind of an initial velocity for the x and y, and then this will still be my kind of magnitude. I think I am, because I'm going to use those variables a lot in the other equations. Actually, yeah, let me double check. Yeah, that'll be the issue. So yeah, I'm not going to return these variables because it'll be kind of hidden. But one thing that I think I am going to want to do is just at the start here, yeah, I'll have my loop count. I want my like Vnaught in the x direction, V in the y direction, so those both equal to none, and that way on my first pass through, instead of looking at variables, I'll just look at that. But then when I'm going through the other equations, I'm going to have to use yep, we're doing it. I want it to be nice and flexible, so I have no idea what kind of input I'm going to have to deal with. Do I want this to be, yeah, I guess it is possible that you have a problem where you're like, where yeah, like you're driving on a truck and something, and then you shoot the bowling ball up and it comes back down type thing. Thinking. I don't want to do it. And that's too damn bad. So many motherfucking variables. Alrighty, this will go there, that'll go there. This wants to go like that. Boop. Final. Initial x velocity. Why are you being like this? Why? Okay. Got that there. Final initial y velocity. Vnaught y label, throw it there. Increase the row count. Vnaught y text grid. There. And there. Okay, I'm just gonna run this. No? Holy crap, so many things. Initial, final, time in the air. I need to increase the width of this. I'm getting cut off there. First goal width equals 15. Wait, no. No, come on. What I need, clear button, solve, label row count, graph. How do I... Because this is clearly going wider. Is that actually being trimmed? I guess that's not being, nothing's being cut off there. It is just tacking that on, moving that over there. Okay, I'm actually okay with this. It's just that R looked so weird. Like, it looked like this was being cut off here, but the R is just really tiny. I guess the R is pretty short. Okay. So we got that. What are you yelling at me for? Your battery is almost dead. Cool. So I got all of those. Vnaught y. Doop. Tack some zeros on there. Some zeros in front. Cool. We are good. We are a good programmer. Yes, I am. Okay, got all that. Row span 20 because I want that to be nice and fat. So now down here I have my X, Y. I need to grab these. Change all of these F's to zeros. I think that's all I need. Okay, alrighty. So boom, got that. And that is none. Then I want to pretty much just do variables Vnaught x equals variables Vnaught times numpy. This is the x, so I gotta make my little triangle here. I'll reverse it for you guys. Got my triangle, it's going up like this. Alright, I'm not even gonna bother trying to reverse it for you. None of you are watching. There, I want the x component of that, so it's gonna be cosine. Suppose it could be possible. Like, is there any other projectile motion type problem where I will need to solve for V0 of x where I am not given the initial like magnitude and angle? I'ma just say no. Sure, I could go through here and do the other algebra solving. I'm going to assume that's all I need. Yep. All right, next one. I pretty much have the same setup here. And variables V0 y is none. Then I want to do the same process but with sine. So now that I have those two set up, I can now go through now. Here is the magic. Here's the magic. I should be able to just call one-dimension solver in here because the x and the y are the same. So that would mean that sometimes time is going to be the variable I need to use to kind of tie them together. Okay, so there's definitely going to be a restructuring way that I can do this, where I set this up as like an x variable mask and a y variable mask, and then just treat them as two totally separate things. Yeah, that's definitely how I should have done this, because then, yeah, I'd have like an x variable mask equals, I have initial position, velocity, initial position, initial velocity, but the hard part is, what if I need to get time from the other one? Oh, fuck, I'm too tired for this. Okay, you know what? We're gonna call it a night, because I am sleepy. Really short stream tonight, but I am very sleepy. And so, I'm gonna try to think about this a little bit more. Because in theory, I should just, be able to set up like an x variable mask, like a y variable mask. And then maybe restructure the one-dimensional solver. because they are like fundamentally independent of each other, except for time. Time is going to be like the one shared variable between them. So it might be, but yeah, maybe I try to set up the 1D solver so it just doesn't, there's like an optional input flag for it that's like time that you can like toggle on or off. Yeah, I don't know. I'm gonna have to think about it a little bit more, but right now I am sleepy. I have a dirty kitchen that I need to clean before I go to bed. So we're gonna call it here for the night. But thanks for stopping by, anyone who stopped by, or anyone checking this out in the future. Hope you're having a good one, and I will talk to you next time. Bye. Wait, no. That.